Okay, so now question number 14, paper 2. Question number 14. In a new system of units, the units of mass, length, time and current are 5 kg, 5 meter, 5 seconds and 5 ampere respectively. So they have changed the units. If mu naught and epsilon naught are permeability and permittivity of free space respectively, then in this new system of units, the magnitude of 1 SI unit of root of mu naught by epsilon naught is. Okay. I think we can use speed of light. Mu naught and epsilon naught is dealt with, right? So speed of light is root of 1 by mu naught epsilon naught. We want to get mu naught by epsilon naught. I'll just rearrange. I'll write root of mu naught epsilon naught equals 1 by c. And then we can divide epsilon naught on both sides. So 1 by epsilon naught here, 1 by epsilon naught there. This epsilon naught by epsilon naught will get root mu naught by epsilon naught on left, and that will be 1 by c epsilon naught on right. So what will be units of this quantity? Root of mu naught by epsilon naught. I could write the units as, 1 by c. C was the speed of light. Speed of light will be, if we write dimensional formula, L1t minus 1. If we write units, let's write units. So c is meter per second. What about epsilon naught? To get epsilon naught, we could recall that Coulomb's law. Force is equal to 1 by 4 pi epsilon naught into q1 q2 divided by r square. So we get epsilon naught from there goes in numerator, Newton goes in denominator. So Coulomb square divided by Newton meter square. Coulomb is not SI unit, ampere is, right? So we have to write Coulomb square as, current was charge per unit time. So charge is current into time. Ampere square second square. This is epsilon naught. I'll use that for epsilon naught. Ampere square second square divided by Newton meter square. I will take denominators, numerator to numerator. So we get this. Now this aside, I could write root of mu naught by epsilon naught. I shouldn't have equated here. Here I'm just writing units. So root of mu naught by epsilon naught, the units will be, I'll take denominator seconds. Well, I could cancel it here itself. We get Newton meter square. Again, Newton is not the fundamental unit, right? So we'll convert it into kilogram meter per second square into meter square divided by meter ampere square into second. So what do we get overall units? This will be kilogram, this meter cancel, meter square divided by ampere square second cube. So SI unit of this quantity, root of mu naught by epsilon naught, will be kilogram meter square per ampere square second cube, right? Is it visible? Second cube. So we get this expression. Now let's think about the new set of units. So in new set of units, dimensional formula will still be same. So mass to the power 1, length to the power 2, current to the power minus 2 and time to the power minus 3. Dimensional formula will still be same, but then we'll be using new set of units. So I'll call that new units as kg dash, meter dash, ampere dash and second dash. So in new set of units, I could say in new system, we could write units of root of mu naught by epsilon naught as kg dash to the power 1, mass to the power 1, kg dash into meter dash square divided by ampere dash square second dash cube. We get this, and then we have to compare that with SI units. SI units was kg meter square per ampere square second cube. So let's use the conversion factors now. 1 kg dash 1 meter dash squared divided by 1 ampere dash squared and 1 second dash cube can also be written as 1 kg dash is, they have given every conversion factor is 5, right? New values are 5 times of old value. So new 1 kg dash is 5 kg to the power 1, that's it. 1 meter dash, so that's 5 meter whole square divided by 1 ampere dash, 1 ampere square and 1 second dash. So 1 second cube. What do we get here? 5 into 5 squared, ampere squared. So this was 5 ampere, right? 1 ampere dash is 5 ampere. So 5 squared again, and then 1 second. So 1 second dash gets converted to 5 seconds. 5 seconds cube is 5 cube, and then the rest kg meter squared per ampere square second cube. Now 5 squared cancel. 5 by 5 is 1 by 25. 1 by 25 kg meter squared per ampere square second cube is new 1 unit of that quantity, root mu naught by epsilon naught. So this was SI unit. 1 SI unit is how many times the new unit? So 1 new unit, U I could call it. So SI unit, 1 SI unit is 25 times of new units. So the answer will be 25 times. Then in this new system of units, the magnitude of 1 SI unit, they are asking 1 SI unit, so we have multiplied 25 on another side. So the answer will be 25.
So question number 15 and 16. Paper 2, yes, here question number 15 and 16. Okay, right. This question they have asked, yeah, parallel plate capacitors. Okay, first I will give you side view of the same scenario. Right, this is the three-dimensional picture. Right, this is how it is. The containers, this is the second one. This length is 2 meters. This is 1 meter. Right. This is 1 meter. This is also 1 meter. This is actually, right, three-dimensional view of the given diagram, 3D view. But in your question, they have only given you the two-dimensional picture. Initially, yes, this is what they said. Right. In this only air at a time t is equal to 0, right? This is entirely filled with dielectric constant, that is K equal to epsilon r is equal to 15. Yeah, this distance is nothing but, right, that is 2 meters. Okay, this is 1, this is also 1. So area, I think this one. Area of the capacitor, I think this is 1 into 1. So first capacitor, I will call this as C01, I will call this as C02. Initial capacitance. C01 is equal to K epsilon naught A by D, means you have to take 2 meters, right? So this is 15 epsilon naught area. 1 into 1. This one, 1 into 1. Okay, that is 1 divided by 2 meters. This is air capacitor. Initially at T is equal to air capacitor. C02 is equal to epsilon naught into 1 by 2. So this and this are parallel. This capacitor are parallel. So initial capacity of the system, I will write C. Yeah, I will write on the top. Right corner, we have to use this result. Initial capacity, yeah, this plus this. So 15 plus 1, 16 by 2. So this becomes 8 epsilon naught. Up to here it is clear. Fine. Now what we have to see is, right, yeah, I think I can rub off this part. So what's happening is here, you have punched a hole here. Yes, exactly at the bottom, right? So exactly at the bottom, there is a small hole provided. This is the small hole. Okay. So what happens? Liquid level. Yes, I think I have to change bit modifications here. Liquid level changes here, slowly dropping down. Yes. After certain time, something like this is having a level, right? Why? Okay. And here, this level is falling at the rate of V1. Okay. And here, this level, okay, right, here it is. Let us say it has raised up to, yes, this one will become 2 minus y, yes or no? At a certain time t, yes, at the instant of time t, as it no equation of continuity. This is a broader pipe, this is narrow pipe. A1 V1 is equal to A2 V2, yes. This is nothing but, right, that will be y minus of 2 minus y, okay. So velocity of flux, so liquid is leaking, level is dropping here, liquid level is rising here, right? So here velocity of flux v2. So yeah, here we can write a1 v1 is equal to a2 v2. V1 is nothing but dy by dt, of course with minus sign, capital A1, this area 1 into 1, so this one area A1 is equal to 1 into 1, V1 is equal to minus dy by dt. A2 area of orifice, they have given, please look at the question. Area of orifice root 10 centimeter square into meter square, you can convert 10 power minus 4 meter square, and velocity of flux under root of 2g y, general formula, right? But here it is not y, it is y minus 2 minus y. So under root of 2g into y minus of 2 minus y, okay? So this will become, yes, under root of 2g, okay, sorry, y minus of 2 minus y. Yeah, now it is perfect. So yg, that is 2g into 2y minus 2. So 2 into 2 common factor, 2 into 2, 4, root 4 is 2, 2 into root g into y minus 1. Y is variable, right? So that you have to substitute here. So finally left out is 1, that is minus 1 into dy by dt is equal to root 10 into 10 power minus 4 into 2 root g into y minus 1. So bring this down, dy by root y minus 1 is equal to 2 root g into root 10. So sorry, 2 into root g into root 10 into, yes, let us write here 10 power minus 4 whole multiplied by dt, right? So what did he say? At t is equal to something like that. Question number 15. At t is equal to 500 second. At t is equal to 500. So you have to write, this is from 0 to t, and this is, yeah, sorry, this is 0 to 500 second, and this is 0 to y, okay? So if you do that, right, and integrate that, what you get is y is equal to 5 by 4. If you do the integration, you will get y is equal to 5 by 4, okay? Yes, now we have to use this for solving question number 15. The question number 15 answer, that is 5 by 4, 1.25. Question number 15 answer 1.25. Okay, right. Now let us move on to question number 16. Yeah, initial capacity of system I have told you already. Now at t is equal to, yes, t is equal to 500 second. Yes, I think we can rub off all this part. Right, yeah, even this also. This is 2, this y is equal to 5 by 4. Here this is 2 minus 5. 2 minus 5 by 4. I think it is 3 by 4, and this will be, right. Yes, I think I can rub off this part also. This capacity, sorry, this distance is 5 by 4. Now what is happening is, right, this is air capacitor. This is air capacitor, capacity C1. This is dielectric capacitor. This capacity C2. This is C1. This is air capacitor. This capacity, take it as C3. Here this capacity, take it as C4. Okay, take that capacity as C4. Right.
Yes, sir.
So here these two are in series. Okay, series means effective capacity C1 C2 by C1 plus C2. Okay, C1 I will write the data. C1 is equal to epsilon naught into area 1 divided by this distance. How much? If this is 5 by 4, this is 3 by 4. This is 3 by 4. So 4 will come here. 4 epsilon naught by 3. C2 is equal to dielectric K epsilon naught A by D. So K means it is 15. 15 into epsilon naught, area is 1 divided by, this is 5 by 4. 5, 4 will come here. So this is 12 epsilon naught. So effective capacity of these two, yes, I will write this as C dash C1 C2 by C1 plus C2. Okay, keep this aside. Now C3. Yes, let me rub off this part. C3 is nothing but, yeah, this is air capacity. Epsilon naught A by D. Area is 1. Okay. D means it is 5 by 4. So epsilon naught into 1 by 5 by 4. This is 4 epsilon naught by 5. C4. Yeah, this is dielectric capacity. K epsilon naught A by D. K means 15 into epsilon naught into 1 divided by 3 by 4. I think this is 20 epsilon naught. These two are also series. Effective capacity, I will take this as C double dash. C3 into C4 by C3 plus C4. Okay. Now this and this, okay, they are in parallel. C dash, C double dash. So final capacity at T is equal to 500, at T is equal to 500 second, capacity, final capacity C dash plus C double dash. If you do that simplification, guys, yeah, what you get is CF is equal to 1.69969 epsilon naught. Initial capacity, yes. Initial capacity of system, I think, yeah, in the previous discussion, initial capacity, this is what you got, okay, 8 epsilon naught. So what is the difference now? Yes, I think we can make use of the space. Yeah, this I think now I can have it off. Right, so the difference is 8 epsilon naught minus 1.969 epsilon naught. This is given as 8 minus n epsilon naught. 8, of course, it is there, that n becomes 1.969. Truncate to decimals, no. So n is truncated 1.97. That is your answer. Good.
JEE Advanced Paper 2, question number 17 and question number 18. Basically, this is a paragraph type questions, and we'll first go through that questions. That it is given that question number 17. It is a uniform circular disc is there, and the radius is given, that is 0.2 meter, and the mass of this disc is given, mass is given 1 kg. Another data is given somewhere at point P. One small particle having mass m equal to, it is given 20 gram, strikes at this point P, and after striking, it is going at an angle 90 degree along the y-axis down the plane. Okay, so basically whenever these things happen, question is that after collision the particle moves along the negative y direction at a speed of 90 meter per second. Initially it is moving with 100 meter per second given, and now it is moving with a speed of 90 meter per second. Now question is, find the after the collision the disc starts to rotate around the point C. So first thing we will see here, torque about the point C will be equal to 0. If torque is 0, then I can say initial angular momentum is equal to final angular momentum. That because when the torque is 0, then angular momentum is getting conserved. Now initial angular momentum of this particle will be I will write like this thing. See here. So first one is m, that's for particle, mu into. When it is going to hit at this point, I need to calculate this distance, perpendicular distance. Till this much is r, this much. If it is striking, and the question it is given, it is striking, or this one angle is given 45 degree, this angle. So obviously this distance will be, I can write r cos 45. This distance will be r sin 45. Now, so I can write for the first one mu r plus r cos 45. Done, because this much angle is r and this much will be r cos 45. So total one will be mu r plus r cos 45, and the final one will be that mv only for this particle is going. So this is supposed to be the perpendicular distance. This one will be r sin 45 plus with. Why plus? Because after striking, this disc will also rotate. So it is rotating with an angular momentum of I into omega. This is id. Now this is point C. It has to rotate about this point C about this axis. So how to calculate the moment of inertia of this one? Now we will consider another axis here which is passing through the center O. So I will write this one, this id omega I will write like this, half mr square, that is the moment of inertia about an axis passing through the center, plus mass into this distance square. I am using the parallel axis theorem. Okay. Now if I will write these values, that m will be 20 by 1000, this is velocity is 100, initial one, this one is 0.2 plus 0.2 by root 2 equal to, then this one will be again 20 by 1000, okay, multiplied with v will be 90, again 0.2 by root 2. If I will solve this part, here capital M you can put that 1 kg and r equal to 0.2. This part becomes how much? Na 3 by 2 mr square. If I will put that one and I will solve this one, you are supposed to get omega as 7.138 radian per second. Okay, omega equal to 7.138 radian per second. Now question is what? Now question is, after the collisions, how much the maximum height it will change. Now I will apply conservation of mechanical energy. Conservation of mechanical energy. Now see here what I am doing. Now half I omega square equal to mg into delta h. Done. That is the delta h is the change in the height of the position of the center of mass. Okay, so I am getting half I, it is not exactly the center of mass, it is the center, how much the center will get shifted. So half I will be 3 by 2 mr square, whatever the things we have got from here. Omega is 7.138 whole square. Small m is that mass is given. Okay, that is the capital M, that is 1, mass of the disc. Z is given 10. I need to calculate this delta H. So this one I am getting 3 by 4. Capital M is 1 kg. Capital M is 1 kg and R will be 0.2 square, 7.138 square. This one will be 10 delta H. So if I will solve this one, I am getting delta H on 0.15 meter. Done. This is the question number 17. Now I will go to the question number 18. Question number 18 is what? Find the amount of energy loss in the collisions. Find the amount of energy loss in the collisions. Now for question number 18, first we will calculate the initial energy. For the particle, initial energy is simply half mu square. So that will be half m will be 20 gram is given. So 20 by 1000, u is given 100 square. If I will solve, I am getting initial kinetic energy as 100 J. I am getting 100 J. Now the final one. After when it will strike this, this particle will strike, then there will be one energy along the y direction. Okay, as it is moving along the y direction, so it has the certain kinetic energy, as well as another thing is that the disk will start to rotate, which is initially at rest. If it is initially at rest, so that's the kinetic energy of the disk is 0. So I am getting here half mv square plus that energy will be half I omega square. So now half this m will be 20 by 1000 v square, that is 90 square, plus half I will be 3 by 2, capital M is 1, R is 0.2 square, 3 by 2 mr square, omega is 7.138 square. Okay, then if I will solve this one, I am getting this part as that we are getting this part as 80 something, 82.53. We are getting 82.53. Now change in energy delta E will be energy initial minus energy final. This one will be 100 J minus 82.53 J, which will give you 17.47 J. 17.47 J. Okay. So as we are doing the initial minus final and we are getting the positive energy, so that means energy is lost. This much is done. Thank you.